Okay, we have approximating solutions here, and this will kind of dive into how we guess and estimate a solution or something along those lines. So let's just review the process here. And sometimes you'll do this with just looking at an equation, looking at a graph, or something of that nature. Or sometimes you can just, yeah, look at the equation on any problem and just kind of be able to guess what is going on with it just by seeing some of the numbers. Now we have, let's see, the question. I'll have you do the questions and stuff on your own for this, unless I feel the questions are beneficial for you or the tutorial or something like that. So graphing to find a solution. Here's how you have to get the numbers, like everything on one side. And then once you get everything on one side, then you are able to solve the equation. So this, we have a quadratic equation here, and it shows you where the x-intercepts are. So a quadratic equation, you typically have two x-intercepts. Why? Because it'll usually be some type of U shape, and it'll go on each side of the x-axis, like positive and negative, is typically how you would see something like this. So here you have two equations here, and combine them. So a function, let's read the definition real quick. It says a relation between two variables in which each value of the independent variable x maps to one and only one value of the dependent variable. Okay, so let's get into this. Let's see what's next. Now we have this equation here. Well, two equations to the left and the right side, because there's two different equations technically right here. To distinguish the left side and right side, you use function notation, meaning that that's how you can tell the two equations apart. F of x equals g of x. So both equations equal each other type thing. And we have the two graphs here, how they're graphed out. Okay, let's go on to the next part. Okay, so here's the question, and I'll let you do these on your own. Two different types of graphs here. And let's see what's next. So you would determine the number of solutions with it. Probably you would say this would be based on whether or not the graph is touching each other. So as you see in graph A, there's 0 solutions. Graph B, there's 2 because they touch each other twice. Graph C is 1 because they only touch once. And then graph D is 2 because they touch each other twice. Okay. And let's see, let's approximating solutions. Let's see what's next with this. Successive approximation, the process of approximating the intersection of two graphs by taking upper and lower bounds, then narrowing them until a desired degree of accuracy is attained. Okay, so let's see what's next. Okay, so then this solution, these two graphs would have two solutions because they touch each other twice on the graph. So that's what that would mean. Okay, let's go here. This one also has two solutions. And let's go. This one has one solution. Okay, graphing calculator. These questions, I'll have you solve this on your own. Watch that on your own as well. So here's the solutions. Here's a table. So the table would also help you determine the number of solutions on the graph as well. Because then you can see at which point they would cross each other on the x-axis or y-axis, and then you could see how many solutions it would have. Okay. Let's go to the next part. And let's see this. So this is just showing you different examples, how you would solve it. So this one has the one solution because they cross just one time. So both graphs cross each other one time. And let's go to the next part. Let's see. Okay. So the questions, again, I'll have you do this on your own. It's just basically guessing this number of solutions. So the graphing calculator, if you have a graphing calculator, this would go into more detail about, you can see the different graph solutions, all that fun stuff. Table of value helps determine whether how many solutions there are, if there's any solutions with two equations. An approximation, guessing the different values. So then hopefully this gives you a better understanding, or a little bit better understanding, of approximating solutions. And hopefully that clears it up a little bit for you.